Assalamu alaikum everyone. We are going to start with our week 4 topic. I will deliver the lecture in two parts. In the first part, we will focus on solar thermal energy applications that will cover the topics like solar water heating, solar distillers, and how we can use solar energy for thermal comfort and also passive heating. And there will be some case studies that you will be later on tested on. Let us have a look at the source, which is the sun. The sun, if you are thinking about the black body temperature and considering this thing as a sphere, okay, a sphere where inside there is continuous fusion reaction is going on. So we can understand it's a nuclear reaction and it's producing huge amount of heat. So the huge amount of heat is found on the surface, and we consider it as the black body temperature, which is basically the effective temperature coming from a black body when we consider sun as a black body. So it's around 5777 Kelvin. In degrees Celsius, it is around 6000 degrees Celsius. So this one, like we are quite confident that somewhere around 6000 because we can measure it from the surface, right? By analyzing different types of spectrum, we can measure the temperature. But what about the interior? The interior where the reaction is going on, we really cannot directly measure it because we cannot study the spectrum inside. So it can vary as estimated between an 8 to 40 million Kelvin. Yeah, very huge amount of temperature, right? So never mind, we are able to survive on Earth because of this 6000 degrees Celsius temperature, okay, and because of this temperature difference between sun and the earth, the heat is transferring from the sun toward the earth's atmosphere. So let us see how much heat energy is receiving the earth. The earth receives approximately 174 petawatt. Petawatt is it's a unit of power equal to 1 quadrillion watts. What is quadrillion? It is 10 to the power 15 watts, huge amount of energy. Uh, when it tries to reach the earth, about 30% of this is reflected back into space. So it is leaving roughly around 122 petawatt entering the earth's atmosphere. And even if it's entering the earth's atmosphere, it's not directly reaching us all, because in that case we will all be like already be boiling and evaporated if this amount of huge amount of energy is directly reaching upon us. So how is it possible for us to live or survive on earth? Because we have the earth's atmosphere, the clouds, the land masses, and the ocean. So remember, this ocean is the major stakeholder of absorbing this huge amount of energy. Why? Because 70% or 75% of the earth is covered by the oceans, and oceans are salt water, more or less the salt water or water, whatever, they are having approximately like 4.2 kilojoule per kg of specific heat, right? Per kg Kelvin of specific heat. So this absorbs the energy coming from the sun in a significant amount. As we can see that the sun is sending its energy and it is being absorbed by the sea in a major amount. So therefore we can think of a system where we can heat up the water using the solar thermal energy. How can we do that? We can just leave the water in the sun. That is one thing. It has been used from very old time already. Sometimes the newborn babies, the parents, they don't want to boil the water, they want to leave the water in the sun so it will be naturally getting heated, then they will be using it to shower the baby, right? So this kind of delicate use. Nowadays, since we are lacking in the fossil fuel already, so people started to explore whether we can start using or utilizing solar energy to heat up the water for our own usage at a household. And we can use it in the industry also, because in the industry that is relevant to thermodynamics, heating up the water plays a major role, right? I believe you have studied about the power generation cycle like Rankine cycle, where plenty amount of water is heated using plenty amount of heat, right? So if we can replace that heating fuel by the solar energy, it can be very much benefiting for us. So it provides a clean and renewable sources of hot water, reducing the reliance of electricity, natural gas, or fossil fuels. So sometimes during winter, we need like hot water showers, right? If your country has winter, then definitely nobody want to use the normal tap water for shower because it's very cold. So we turn on the heater. But if we can actually use the solar energy to heat it up, right? So that one will be some saving on our electricity bill. That is from the perspective of household usage. It can be used in industry also. And the beautiful thing is, besides its environmental friendliness, because it's not producing any carbon dioxide like burning fossil fuel, or it's not causing us the gas bill, electricity bill. Beside this, another beautiful thing is the solar water heating is very simple. It requires low maintenance once installed with long system lifespan. It can easily go around 15 to 20 years. Okay, and this one is like very much applicable to Middle East countries where solar energy is mostly direct and abundant and year-round. It can be applied in domestic, commercial, and industrial sectors. That means we can use it in homes, hotels, hospital, laundries. We can use it in airports also. In Singapore airport, which is one of the largest airport in the world, Changi Airport. My professor, under whom I did my PhD, he installed a solar water heating system for the airport's dishwashing purpose. Because airport, many flights are coming and they are clearing out their cabins, all the used up dishes and everything. So they installed a solar water heating system on the top of the Changi Airport, and that one saved huge amount of electric energy, because for washing the dishes around 60 degrees Celsius is good enough to kill all the bacteria and germs. So they install it, and it's very easily possible to raise the water temperature if you leave it on the sun in an optimized way, or with an optimized design. It can go up to as high as 90 degrees Celsius also. So they install it and they actually reduce the electricity cost for washing the dishes. Okay. Now let us have a look on how many types are there. One is thermosiphon, one is forced circulation. So the difference between them is thermosiphon is a complete passive system. It does not use any type of external energy, but still it is possible to circulate the hot water and the cold water by optimized design, by an optimized design. And the forced circulation, as it indicates, is an active system. That means it will require some extra energy from outside. So it will require a pump, and the pump will require electricity from the source, right? So you'll have to supply some energy to it for this forced circulation. And for the passive one, you do not need to supply any kind of pump or any energy. It will just travel by gravity and the properties of hot water traveling upward. Okay, now let us have a look at the thermosiphon system. For the thermosiphon system, there will be a storage tank, okay, and the water collector tubes are inclined to absorb the sun's irradiation. So you can see in details, you know that hot water will always try to travel upward, and the cold water is heavier, so it will go naturally bottomward. We apply this technique in this thermosiphon system. So from this tank, by the gravity, the water will flow downward, right? And why is this inclination? To absorb optimized amount of the sunlight coming here, right? That's why we use it as inclined. Also, it will give us the way for the cold water to travel down. You can see the cold water is indicated by the blue color. It will travel down, and the hot water will get heated because the solar irradiation is falling on the tubes, and it will get lighter in density, and it will travel upward to the tank. And when it enters the tank inside, the hot water will be stored at the top because it's the lightest object, while the cold water will be staying at the bottom, and this thing will continue by the siphoning system. So it gives us the freedom of not using any pump. You do not need to connect it to any electrical resources to run it. So as long as you just install and leave it on the rooftop, it will be always storing back hot water into this tank. Now let us have a look into the forced circulation system. In this case, the heat exchanger principle will be applied, and we will be using this hot water from the sun as a source for heating the water inside the container. The container is here, we can see, and we can see the source of heating is coming from the forced circulation system. And the water channels, you can see the water channel, the yellowish one is the warm water, then it is traveling up by the pump. There is a pump here, so it's traveling up and it's pumped, and it is getting heated by the sunlight, and it is coming out as hot water. It will go down to the, because of gravity, it will have to go down to this coil, and this coil will be exchanging the heat with the water stored in the tank, right? So we have to install the pump, we have to install the temperature sensor, and then the controller. You have to install this heat exchanger. So overall we can understand only the water heating system is already costly. And for your forced circulation system, you also need to design the collector in a special way. There will be a glazing panel at the top that will protect it. Under the glazing panel will be the water tubes distributed, okay, and underneath it will be the insulation, because this thing acts as our heat source, right? This water is not directly mixing with the tank water here. It's not directly mixing. It is just used to heat up the tank water, and we are using the same fluid, okay? From the absorber, we are using the same fluid circulated. So overall, this one is more expensive, definitely, but it is more efficient as well, because when you need like plenty of hot water supply, the thermosiphon one is not sufficient, and you need to supply to the hospital or industrial purpose, then this one is more suitable, because for industry purpose installing a pump is no big deal, because pump naturally they don't consume very high power, because pump is used to only pump water. So when you're pumping water, the change in enthalpy is not that significant across the pump, unless otherwise it's an extremely large system. So it is also suitable for larger multi-story buildings beside the industry, and but you have to actually compromise with using energy from the pump. It is also more suitable to be used in the weather where there is a formation of frosting snow, okay? So it is more suitable. That's why in Europe, where there is a chance of snowfall, they will use this type of system instead of the natural thermosiphon system. Now, some more facts about forced circulation system. This is the form most common in Northern Europe, as I have mentioned, because of the climate, because they will have some snow, okay, in some time they will have some snow, and if you just leave it as a natural circulation, then the water inside will get frozen and it won't flow anymore. But if you have this forced circulation system, by the way, forced circulation system will usually have the auxiliary heater as well. And for the thermosiphon system, it goes the same. There's auxiliary heater because, for example, if it's very cold or there has been like cloudy days for at least 2 to 3 days, I mean, you do not get enough sun to heat up the water, we still can use the tank as our hot water supply source, but for that we will have to have the water heater. Okay, so auxiliary heater, that one will work only when the sun is not there. So forced circulation system, this one is like as I have mentioned, it has a collector panel, a storage tank, and a pump circulation system. Then comes the components in details. So you can see what happens here. It's not a continuous flow like thermosiphon. At the top there is one liquid outlet and at the bottom there is liquid inlet, right? Why do we design it like this? Because the hot water will always have the tendency to travel upward because it's light. So that's why we put the liquid inlet, which is relatively cold, right, and heavy at the bottom. So it will come in and then the hot, it will, since I'm using the pump forced circulation, it will be pumping it through and it will be getting heated, it will be getting lighter, and then it will come out as the liquid outlet as hot water. And these two inlet and outlet, they are connected by parallel pipes. Okay, this is a good way to ensure that each of the pipe is receiving the solar irradiation equally. Okay, so there is a cover sheet, absorber plate, and they will paint it like black for a better absorption. And there will be insulation at the bottom because, as I have mentioned, this water is our heating source. So we don't want to lose the heat by a poor insulation. Some more detailed facts about forced circulation system. It's usually 3 to 5 meters square in area, tilted to the face, the sun, and it is mounted on the normal pitch roof of a house. Okay, this panel normally consists of 3 components: glazing, absorber plate, and insulation. Please take note, I'm always reminding you of these 3 components: glazing, absorber plate, and insulation. The absorber, it is a steel plate bonded to copper tubing through which the water circulates. So it's a plate, the steel plate is there, and on top we fix the copper tubing. Okay, it's an assembly. This plate is sprayed with a special black paint to maximize the solar absorption, and it is covered with a glass or plastic, and the whole assembly is insulated on the back to cut the heat loss. So if you compare the thermosiphon and the forced circulation system, by looking into them you can already determine which one is the thermosiphon and which one is the pumped solar water heater. So the thermosiphon will have the tank, okay, this round shaped tank, the top. When you see this, you will understand that this is the tank, because this tank, the water is directly going into the storage. While for pumped solar water heater, the absorber plate, I mean this collector, is only outside and it is going somewhere to heat up the water in the tank. Okay, so when you just see this plate, you can understand this one is the forced circulation, and the pump and everything is placed somewhere else, not here. It is here only to receive the heat from the sun and work as the heating fluid. While thermosiphon, the whole thing comes as a one assembly, the tank associated with the water heating tubes. So if we do a side-by-side comparison for thermosiphon and forced circulation, so first one definitely is natural convection versus pump driven circulation. Then system complexity, definitely thermosiphon is simpler and with fewer components, and forced circulation has to be more complex. And installation, the storage tank must be above the collector, otherwise the thermosiphon principle will not work because the hot water has to travel upward. And for forced circulation, although it's suggested you can actually place the hot water outlet on the top, but there is still some flexibility of the tank and collectors as well. Initial cost, thermosiphon is low. Initial cost for installation forced circulation is higher, definitely. Operating cost, almost none, but forced circulation will require electricity. So it will have to count some bills, right? Maintenance, thermosiphon is very simple, and for the forced circulation, definitely you have to maintain, you have to check on the pump performance and the control require servicing, all these things. Efficiency is the one of the bottleneck for thermosiphon because it is moderate, depends on natural circulation. And for forced, definitely the efficiency is higher. And suitability for thermosiphon is for the small household, okay, small household, small scale application. But when you have to move for a large scale system like hotel, hospital, industry, for mass scale, you should install the forced circulation system to actually maximize the availability of area, okay. And reliability is the lesser the electrical equipment, the higher the reliability, right? So thermosiphon is very reliable, while forced circulation definitely will have the risk of pump or control malfunction. And climate, okay, thermosiphon will work best in the Middle East and North Africa region where there is plenty of sunlight throughout the year, there is no cloud, okay, warm climates. However, for circulation, it can be optimized for varied climates. How the water is heated on the rooftop. Now we are going to talk about a special application of solar thermal heating in solar distiller. Solar distiller are nothing but a tray of water which is usually not pure form. It can be seawater, it can be wastewater, or any form of unpure, not pure water. We leave it in the sun, so we know that when we leave some water in the sun, it will evaporate faster, right? So what we do is we try to create a greenhouse effect. So we take this, maybe I give you an example with the drawing here. So we take the water, this one is called the basin that contains the water. And inside the basin we pour in the water, and then to create the greenhouse effect, we cover it with a transparent cover. And we have to make this cover inclined because when the solar irradiation will enter, here it will heat up and increase the evaporation. Please take note, the water never boils. Okay, we cannot make it boil in a normal condition, but we can make the temperature go higher inside the chamber. So it works as a greenhouse, and as a result, the higher the temperature, the higher will be evaporation, and uh, the air inside will become saturated with water vapor. As a result, the water vapor will reach up to the inclined transparent plate inner side, and then it will condense. And if we can make an optimum angle of this inclination, all these condensate will come out and drop as distilled water. This is the principle of solar distiller. So there can be like the first one is a double slope, right? So we don't have to bother about whether the sun is on which side, whether east or the west. So it will be receiving the solar heat during the daytime. This one is a single slope. Okay, single slope. So single slope and double slope. There are many other designs in the solar distiller slope. We'll talk about that. Now we focus on the types of basin. You have seen that the basin is basically the container where we place the water. So there are, like, depending on the basin structure, there are mostly three types. Okay, one is a single basin, multiple basin, and the other one is a stepped basin. So for the single basin solar system, it's just a simplest form, and it is limited to low production, low productivity, but it has obviously low cost. For multi-basin solar field, it is using a collector, solar collector. So the
sunlight is heating up the water sphere inside the solar collector, going to the first stage. So when the first stage, the water evaporates, it will go up and it will condense, and it is designed in such a way that the second stage basin is linked to the condensation surface of the first stage. So the second stage receives the heat of condensation from the first stage. And similarly, each of the subsequent stages enjoy receiving the heat of condensation from the previous stages. And the final stage, we can make it also open to sunlight, so to enjoy the extra solar heating. And so this one is your construction is definitely more complex, so therefore higher cost, but it has like more production compared to the single basis. Now we will talk about the uh, step solar cell. So for the step solar cell, you can see that the basin is divided like something like a stair, right? So one, two, three, four, five, six, seven steps there, and we distribute the saline water in a thin film over this there. And in this way, we are not making the thing very complex, but we are simply increasing the evaporation surface area. So we distribute the water and we increase the surface area. The higher the surface area, more vapor will be generating from each of the surfaces. Right? So this is how this works. So the evaporation occurs faster. Also the productivity is increased. But yes, compared to the uh, single basis, definitely this one is more complex fabrication. Let us have a look at based on condensation surface, that is the inclined surface, we say, the transparent inclined surface. How can we divide the solar distiller? The solar distiller mostly is classified among single slope and multiple solar slope still. So you can see for the single slope there is only one slope. For multiple slope it can be double, like a house, or it can be like a pyramid, and sometimes it can be made like hemispherical as well. So it's the main reason to provide multiple slope is to receive sunlight from all the directions. So when you have multiple slope, you have more condensation surface, as a result you have higher output. The other types of solar cell can be described as one is inclined solar cell. In this case, the whole basin it is inclined. Okay, so the whole basin is put inclined, and then we have to create a falling film of water. A thin film of water will be flowing. So as a result, since the water film is very thin, it will evaporate very quickly and immediately produce the condensate. But definitely maintaining the water flowing film is not so easy, right? It will need a very controlled design. So therefore, it's pricey, but its advantage is high evaporation rate. Another one is weak type solar cell. Weak is a kind of like cotton material. So this uses a porous weak material to spread the water in a thin layer. Usually they are black in color. So cotton material, right? So cotton usually will soak, absorb water. So similar way, this wick actually absorb the water, and by capillary action, the water flows along the wick and a faster evaporation is obtained. So it's very high efficiency. It's for intermittent water supply, but the problem is the wick material, right? So you're using something cotton-like bio material, which will degrade over time. There might be generation of harmful bacteria, so it will require replacement. Now we talk about the design consideration of solar distiller, basin material and insulation. So these two things are like the basin material should have, inner material should have good absorption capability. Usually we made it up with stainless steel because we can use different types of feed water. So we can use seawater, salt water, and stainless steel is easy to shape, so we can shape up the basin easily compared to ceramic or other breakable materials. But the outer side should be well insulated. So once the solar energy is reaching the water, water is getting heated, the hot water cannot dissipate the heat outside back again. Right? And thickness of feed water level, that one is very important. Normal design is like 2 centimeters of water depth is good enough in the basin. Beyond 2 centimeters, it has been reported that most of the solar thermal energy is used up just to increase the water temperature slightly because water has a high specific heat capacity, 4.18 kilojoules per kg Kelvin. So to increase 1 degree Celsius of 1 kg water. So if you actually put up too much of water, so the depth is increasing, that means your water volume is higher. In that case, most of the solar energy will be used to heat up the water only and it won't reach evaporation to heat. Then again comes the transparent cover. Okay, so for the transparent cover, it has been investigated that glass actually gives you the better performance. Okay, in terms of letting the sunlight going in and creating the um, greenhouse effect, plus glass can work for a long time if it's not broken. Can work long time without getting like hazy or marred, but the performance is not so good when we use perspex. Okay, perspex is like it will get scratched easily, and also the inclination angle, right? So inclination angle is we have learned that in the previous lecture that zenith angle will determine the sun's vertical position. Um, so if you can incline your collector or in this case the transparent cover angle is inclined towards the zenith angle, it's supposed to capture the most of the sunlight. But you have to keep another thing in mind that if we are using the slope as a condensation surface, after the water condenses, it will sit along the slope. So if you see that I have a normal like 30-degree slope, good enough. If you have a very steep slope like this, so the water droplets will condense and then there is a chance that they will fall back to the feed water. So at the end, we are getting not useful amount of water that we produce, right? So this slope is usually kept around 30, 25 to 30 degrees. Then the number of slopes definitely the more that you're exposing to sunlight and efficiency enhancer can be like using wind. Sometimes we use PCM, that is phase change material. When you have the water in the basin, right? So there is enough sunlight coming in the daytime, okay? And then if you are having it over a phase change material bath, the material that is solid, it will melt due to the sunlight. Phase change material is something like wax, paraffin wax kind of material. They will melt when the sun hits the water gets heated, the heat from the water transmitted to this phase change material, they will melt and they will store this latent heat of melting. So when the sun goes down or there is cloud coming in, then it will be giving up the heat to keep the water warm. Okay, so that one is used for PCM. And one drawback of PCM is the PCM thermal conductivity is not very good. So it may be like that if the sun is heating the water, and only the portion of PCM will melt, the rest of the portion won't melt because maybe the conductivity is not good. So sometimes they use nanoparticles with the PCM. Or nanoparticles sometimes are added with the water directly to have a better conductivity. So we have covered about solar desalination. There is one application of solar thermal energy. We are going to discuss about other application of solar thermal energy in our next lecture. I'm going to finish this lecture with these things like thermal comfort and passive solar heating. Okay. So how can we attain the thermal comfort? Thermal comfort means either in a either in the summer you arrange for something like cooling, or in winter you do the house heating. Okay? So how One type is Trombe wall. So Trombe wall is a dark, massive wall with glazed exterior facing sun. So it absorbs solar heat by day, releases to the indoors at night. So it can give to keep the house warm at night in a cold climate. And the solar chimney is actually used to provide fresh airflow and cool airflow. It is useful in hot climate. You can see on the right hand side, this is the solar chimney. So they expose the chimney to the sunlight. So when the sunlight falls upon the chimney, inside the chimney, the air will get heated and the hot air will move upward and it will make room for the fresh cool air to enter. So it is useful in hot climate for cooling and fresh air circulation. We do not have a fan or air con. Now we will talk about case studies that one will be covered in your quiz too. You have to study about solar water heating in Middle East and North Africa region. Okay, and passive heating in temperate means moderate temperature with different seasons, avoiding the extreme of both tropical or polar climate. Okay, so there should be a four-season climate. How can we do the passive heating in four-season climate? Besides these two, I will also include some questions about solar water collector overall design and also solar distillation or solar desalination. Okay, so I will provide you a detailed list. So you have to research on that and then I will prepare a questionnaire for your quiz. These are the summaries we have learned topic. The next topic will continue on solar thermal applications too, where I will talk about concentrated solar power and how we can produce power with concentrated solar power or what are the other uses of concentrated solar power and how to obtain them.